Hey everybody, moving into 8.2. Now I am going to say that this is 8.2 part 1 because 8.2 covered more than what I thought it should in one lesson. We're going to break 8.2 down into a few things. So we're going to start right here and we're going to multiply a polynomial by a monomial. Okay, and you can see we're still in the same eligible content that you're going to see on the keystones. When we multiply, you can see that keyword multiply polynomials. So here is the main rule for distributing a monomial. When you distribute a monomial into a polynomial, you need to multiply coefficients. Multiply and I don't know why it looks wrong. Multiply, there you go. And I need you to add the exponents of any variables. So if x has an exponent and x has an exponent, add it. If a has an exponent and x has an exponent, you only do the ones of the bases that match. So don't add different variables' exponents. After you're done, you need to combine like terms. And I have an example here. You'll be given maybe a monomial times a polynomial. And let's work that one down. So here's the distribution arcs of that one. And you end up getting 2x to the fourth from the first arc and 7x squared from the second arc. And then here's your second polynomial being multiplied by a monomial of -3. There's your distribution arcs. You can see the -3 goes to the 2 and then the 4. And this is the result of what you get when you multiply both of those distribution arcs. And then last, but certainly not least, one of the steps we learned from the previous lesson, combine those like terms. So these ones right here got put together. Now we're not going to start with that's one of the most difficult ones you'll see all day. Just wanted to give you an idea of where we're heading. But let's start nice and easy. So simplify the following. We're just going to punch out all of them. I don't think it'll take more than 15 minutes. It's probably important that you put a 1 until you're absolutely certain. You're like, yes, I know there's a 1 there. It's not a bad idea for you to put those 1s. Staying consistent, why don't I just use purple and blue today? And then I'll use more if I need. So this arc, when I multiply, 1 times 1 is 1. And h to the first times h to the first is h squared, 1 plus 1. Now I'm going to take that and I'm going to go over here. So 1 times 4 is 4, and that was positive. And I only have the h to the first power, so I just put an h on it. So I took, let's highlight the outside term in red. I took the outside term, and I multiplied by the inside first term, and then I multiplied by the inside second term. I'll try to stay consistent with that highlighting for you. All right. My outside term is a -4 and a k. I will need to multiply that first to the k and then to the -9. I'm going to put a purple 1 in front of that k, just in case you weren't sure. And now I'm going to distribute. I'll do purple first. So a -4 times a 1 makes a -4, and the k times the k makes k squared. That's my first arc. The -4 times the -9 makes a positive 36, and then there was a k and no k on that one, so just k. Those are not like terms, so I'm all done. Number 3. I have an outside, I have an outside 6p, I have an inside p, and an inside -8, and then that +3 is just a +3 in the back. We'll leave him alone for a little bit. So the first thing I'm going to do is 6p times p. So it's like 6 times 1 is 6, and p times p is p squared. Now blue. I have 6 times -8 is -48, but since this first 6p had a p, that has to have one as well. So that blue arc, I'll just show it to you one more time, makes a 6 times an 8, which is 48, but because the 6 had a p, I had to include it in that. And then the +3 is just going to come down. None of these are like terms because they all have different exponents, so I'm done. Number 4. Let's see, I have this -4c in the back. So I have to distribute a 3c into a -2c and a negative 5. So the first one I'm going to do is 3 times negative 2. My coefficients make negative 6. And don't forget, we had a c on there. Because it was a c and another c, that makes c squared. Now I'm going to take this 3 times a negative 5, which makes negative 15. And because the 3 had a c, this has a c, but only to the first power because the 5 did not have a c. So it's only c to the first. And then I have that minus 4c behind. Do you see any like terms? I hope that you can understand that those are like terms. I'm not sure why my pen did that funny dragging. Let me try that again so it doesn't look like a weird box. There you go. Those are like terms because they both have c to the first power. So let's see, what is negative 15 take away 4? Well, negative 15, let me turn the calculator on. Take away 4 is negative 19. So this is negative 19, but don't add the c's, just leave the c alone. Remember we learned that in the first lesson. We do not add the exponents. Negative 6c squared. All right, let's go again and do number 5. Shrink that calculator down. It's a little much for me to look at. All right. Ooh, I have 2 things on the outside. So I'm going to get my red highlighter. I'm going to distribute an x, and then I'll distribute a positive 3. Inside, I'm going to have a purple. I'm going to have 3 colors this time. A blue and, oh, how about a gray? I'm going to do all 3 of those first, and then I'll deal with that second item. So let's see, x times x squared. Well, there's no coefficients other than 1. So I add my exponents, and I get x to the third, 1 plus 2. Next, I take that and I put it here. Let's see, this is a positive times a negative, which is a negative. Both of those x's have a power of 1, so I add them to be x squared. Now I'm going to take this x and go to this 3. Well, the only coefficient I have to really worry about is the positive 3. Technically, there was a 1 in front of that other one. And it's x to the first power. It doesn't change to become x to the third or second because the 3 didn't have an x. Now, guys, we have to do that again. So I'm going to get my purple back, and I'm going to do this one and this one. So I'll just do my first one in purple always, my second one in blue, just to stay consistent. So I'm going to do a positive 3 times an x squared. So it's like a positive 3 times an x squared. What does that make? Positive 3x squared. That's it. Nothing gets added or anything like that. Now let's see. I'm going to do a positive 3 times a 5x. So what is a positive 3 times a 5x? Well, that's just 15 with an x. Now it's time for us to look for like terms. So I'm going to go ahead and get my green. I only see that x to the third power. However, I see this x squared and this x squared. They're both x squared, so they have to get put together. So sorry, those are my kids downstairs. I tried to shut the door. So that's a negative 1 plus a 3 for a final answer of positive 2x squareds. And now I have this 3x to the first and this 15x to the first, and 3 plus 15 is going to make 18x to the first, or just 18x. There's no more like terms, so this is my final answer. Let's look at number 6. All right, so I see a 5m squared in the front. That's going to need to be distributed. And I see a minus 4m squared that's going to get distributed. Let's talk about the first polynomial first. So we're going to have to multiply by 3m squared. We're going to have to multiply by minus m. Ooh, and then I'm going to need another gray. We're going to have to multiply by minus 7. Again, I'll deal with this in a little bit. I'm just going to deal with the first half here first. So the first one we're going to do is, let's see, that's going to be 5m squared times 3m squared. And that's going to give me 15m to the fourth. And that came from that arc right there. And then I need to do 5m squared times a negative m. So times 5m squared with this m. That's going to make a positive, oh, no, excuse me, that was a minus m, wasn't it? I better put a negative there. That's going to be a negative 5m to the third. The negative comes from the negative right here. And then the third power comes from the 2 and the 1. Okay, let's do another one. Boom, 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 boom. So this negative 7 is going to have to get multiplied by 5m squared. So it's going to be a negative 35 when you multiply those two numbers, negative 7 times a 5. And then the m squared hops beside it. Let's take a look at this one. Looks like I'm only going to have two distribution arcs on this side, one here and one here. I am going to take a moment and ask my kids to quiet down. Girls, your yelling is getting picked up in my recording. Thank you. Sorry about that. I will try to edit that out. So my first arc is going to be this negative 4m times that m3. So times negative 4m. So let's see. That's going to be a minus 4m4 because there's a 1 on that. And then this arc is going to be, so times negative 4m. Let's see, 2 times negative 4 is negative 8 with an m. It's time now to find some like terms, if there are any. So I'll change to green for that. So I see a 5m to the 4 and a minus 4m to the 4. Or excuse me, I think I said 5. I meant 15. 15 take away 4 is 11. So I have 11, but remember we don't change the exponent on there. Now let's see here. I have a minus 5m3, and that's the only one that has m3. So he's just going to hop right here. Now I have a minus 35m squared. He's the only m squared, so he's just going to plop down. And then last I have a minus 8m in the back. And that is the end. I can't combine anything else because they have different exponents. All right, we have 4 more. We can do this. So how many distribution arcs do you think we're going to have in number 7? So I have this negative 2x. If you said 3 distribution arcs, that is correct. We're going to have 1 distribution arc here, 1 distribution arc here, and 1 distribution arc here. This plus 4x squared is just going to kind of travel down to be used after we distribute. So I'm going to have to multiply my 6x squared by that negative 2x out in front. So that's going to be a negative 12x to the 4th. I'll make that 2 look less like a z. Let me actually make it look like a 12. Now let's see the blue one. So the blue one's going to be, I kind of like writing this negative 2x underneath of it. Kind of helps me see it better. Well, negative times a negative is a positive. 12 times 2 is 24. And that x has a 1 and that x has a 1, which means x squared. I like that. And now I'm going to take in gray. And I'm going to have to multiply that gray by negative 2x. So a positive times a negative is a negative. 18 times 2 is 36. And I have an x, not an x squared this time. And then remember we said that plus 4x squared is just going to kind of chill. Now it's time to look for like terms. So like terms are things, well, let's see. This one is the only one with an exponent of 4. Ooh, we have this one with an exponent of x squared and this one with an exponent of x squared. So positive 24 plus 4 is positive or plus 28x squared. And then this 36x is the only one of its kind, so it's going to come down next. I think it's a good idea. The more I'm going over this, I think it's a good idea if we write this every time on our problems until we're like totally sure that we're good to go. So how many distribution arcs do you think we're going to use in number 8? Well, I see a 3x that has to go in the parentheses, and I see a minus 5x that has to go in parentheses. So in the first parenthesis, I'm going to have 1. Sorry, I meant to use purple this way. 1 2, 3, and in the second parenthesis, I'm going to have 1, 2. So each monomial goes to the terms on the inside. So I'm going to get the black pen back. I'm going to zoom in. So this x squared that I'm going to highlight in purple needs to be multiplied with the outside 3x. This positive x that I'm highlighting in blue needs to be highlighted with the outside 3x. And this positive 1 that I'm highlighting in gray needs to be multiplied with the outside 3x. I'm going to go ahead and do that now. So this first item is going to be a 3x to the third because it was essentially 1 times 3 and x2 plus x1. And then this is going to be a positive 3x squared because of the 1 times the 3 makes the 3. And the 1 plus the 1 makes the 2. And then last, I'm going to have a positive 3 from the 1 times the 3. And that has a little x because of that x. Now I'm going to go to this parenthesis. So each of these is going to need to be multiplied by a negative 5 and an x. A negative 5 and an x. So this is going to become a minus 5x squared because 1 and 1. I'm going to erase that because that gets really complicated. And this becomes a positive 15 because negative 3 times negative 5, and it does have an x. Now we're going to combine those like terms. I'm going to move this a little closer. Combining those like terms, let's see if we can find the biggest exponent, which is this one. It's the only one of its kind. I have 3x squared, take away 5x squared. 3 take away 5 is negative 2x squared. And now I have a 3x and a 15x, and both were positive, for a total of positive 18x. I can't go any further because there's none others that have the same exponent. 2 more. If you're still with me, I'm so proud of you. All right, let's check this one out. This one is actually review from 8-1. Okay, so if you're like, hey, Mrs. Angeli, I don't see anything to distribute. Technically, there's a 1 to distribute, right? But what happens if you distribute a 1? What's 1 times anything? The same thing, right? So we don't even need to worry about distributing. See this plus sign? I'm just going to add, or let's use the real words. I'm going to combine my like terms. And here we go. I'm going to put them in order, or actually, let's just do it. Let's see if we can find them, guys. So I can see, let's erase this mess here because I already wrote it. I'm going to color them. This is the only one that has an a cube, so it goes first. Then I have 3a squared minus 3a squared, which is actually 0a squared, right? But we don't write 0a squared. Those cancel each other. So I'm going to go boom, 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 boom. And then I have a minus 2a to the first power. It's the only one of its kind. And then last but most definitely not least, I need one more color. I'll just use yellow. I have a positive 3 and a positive 1 to make for a positive 4. So there was no multiplying on this problem, because there's no monomial on the outside of parentheses. All right. Ooh, this one is a subtraction. Don't let it sneak you. Remember, subtraction, we have to put it in to have a minus 5c and a minus 7. So it changes this and it changes this. So my biggest term with my biggest degree is my negative 4c3. It's the only one of its kind. Next, I have a positive 10c to the first and a negative 5c to the first. And if you're not sure, that's 10 take away 5 for a positive 5c to the first. Remember, we don't add our exponents when we're combining. We only add exponents when we're multiplying. And then that little minus 7 is going to hop down in the back. There's no more like terms, so that is the end of our story. In conclusion, today I taught you how to distribute a monomial out in front. For example, this one right here. After we distribute the monomial in the front, we combine our like terms. Remember with adding, like on number 7, or excuse me, with multiplying, you add your exponents and multiply your coefficients, but when you get to the combining step, you don't add your exponents. All right, see you in class.